Climate change and greenhouse gases, the gases that trap heat in the atmosphere, are an increasingly emerging issue on national agendas. However, the role that organic soils play in reducing greenhouse gas emissions is still insufficiently investigated. LIFE OrgBalt explores the role that nutrient-rich organic soils and sustainable human interventions play in reducing greenhouse gases or in enhancing land capacity to reabsorb and store these emissions. The LIFE OrgBalt objectives are: first, to improve greenhouse gas calculations for drained nutrient-rich organic soils by including project territory-specific activity data and emission factors.
The big aim of this action is to elaborate greenhouse gas emission factors, regionally usable factors for our countries and beyond, and that's our really big aim, to implement a national greenhouse gas emissions inventory with better, more accurate data.
Second, to identify and demonstrate sustainable, resilient, and cost-effective climate change mitigation measures.
We are going to implement more than 10 practical greenhouse gas mitigation measures or practices on organic soil in forest land and also in agricultural land.
Third, to provide tools and guidance for the elaboration, implementation, and verification of efficiency of climate change mitigation measures policies.
Currently, we are working on decision support tool for policymakers as regards organic soils, and our big aim towards the end of the project in this regard is to prepare policy proposals for policymakers about organic soil management.
Let's find out more about drained nutrient-rich organic soils and their relationship with greenhouse gas emissions.
When it comes to soil properties, we are interested more in the soils with high content of organic matter, also called as organic soils.
Why?
Well, in a European perspective, drained nutrient-rich organic soils, they produce high greenhouse gas emissions, especially compared to their land area. So they are so-called greenhouse gas hotspots. And if we think about climate change mitigation, then these hotspots play an important role. If we manage to find means to reduce greenhouse gas emissions in these ecosystems, that could make a difference.
Drained, nutrient-rich organic soils are indeed one of the largest key sources of greenhouse gas emissions in boreal and cool-temperate moist climate regions in Europe. The total area of drainage-based, flooded and re-wetted managed organic soils in EU is 33.6 million hectares, or 7% of the EU area. In the agricultural sector in Europe, organic soils make only 3%, or 4.4 million hectares of the total agricultural area, but are responsible for 25% of all agricultural greenhouse gas emissions.
So on a relatively small area, you find huge carbon storage. And the reason for that is that over centuries, over millennia, actually, peat has formed in a way that plant material was not decomposed due to the permanent water saturation of the soil. But now when we drain peatlands, what happened in many countries of Europe, but also beyond, especially in Central Europe, like in Germany and also the Baltic states, Scandinavia, Ireland, we find that oxygen can enter the peat, start to decompose the peat layers, and high emissions go up into the atmosphere.
The project territory represents about 65% of the European Union area and 45% of the organic soils in the European Union.
So the scale of the problem we face in the Baltics is peatlands make around about 2.5 million hectares of the land surface in the Baltic states, and they emit annually 29 million tons of CO2 equivalent. So this is the scale of the problem that we face there and that we need to challenge or to tackle with climate change mitigation measures we apply. And we have to define or evaluate which are the right climate change mitigation measures that would efficiently reduce these emissions.
innovative climate change mitigation measures will be implemented in nutrient-rich organic soils to demonstrate economically, socially, and climate-friendly balanced land management solutions and to contribute to international and national climate policy targets.
So we have in the project two types of sites. One type of site is demonstration sites, or demo sites in short, where we are doing some measures which, according to our idea, will lead to reduction of greenhouse gas emissions or increase of removals in different carbon pools. And another type of sites are so-called reference sites. For instance, for forest lands, if you are speaking about afforestation, we found the area on organic soils afforested about 30-40 years ago, where we can see what is actual rate of emissions, what is carbon stock in different carbon pools. And in that way we are estimating what would be the impact of our measures in long term.
16 demonstration sites will be established in the Baltic states and Finland to identify and demonstrate sustainable, resilient, and cost-effective climate change mitigation measures applicable in croplands, grasslands, and forest lands. Adapted management can in fact mitigate greenhouse gas emissions from organic soils in the agriculture and land use change, and forestry sectors, and preserve the soil organic carbon stock.
Within LIFE OrgBalt project, we are looking out different management methods, and then we are studying how those kind of management methods are affecting greenhouse gas balances.
Comprehensive and updated nutrient-rich organic soil information are needed to understand the potential of these soils as well as country-specific emission factors.
For our institution and for Lithuania, this project is very important because Lithuania as a country does not have its own greenhouse gases emissions factors yet.
Scientifically sound knowledge on actual greenhouse gas emissions is important not just for scientists and technicians, but is of high importance also for policy planners to support them in developing climate policy planning documents.
From the ministry perspective, we don't have comprehensive and updated soil information available. That's why it is difficult to make sustainable resource management decisions, especially in the land management planning. Of course, with one project, we can't solve all our problems. But with LIFE OrgBalt project, we believe to obtain updated nutrient-rich organic soil information and country-specific greenhouse gas emission factors.
The project's expected results are improved knowledge base, enhanced capacity of national and local authorities, contribution to the demonstration of innovative climate change mitigation measures in drained, nutrient-rich organic soils, contribution to sustainable land use, agriculture, and forestry.
The policy planning decision support tool will help farmers and foresters to project the greenhouse gas emission from the nutrient-rich organic soils under different management and climatic scenarios.
The project will last for 4 years from 2019 to 2023 and is implemented by 8 partners from 5 EU member states: Estonia, Finland, Germany, Latvia, and Lithuania.